Hi friends, today I will discuss on an interesting point of our refrigerator, that is defrost cycle. So defrosting is a major part in a refrigerator. Okay, defrosting cycle is a major part in a refrigeration cycle or in a refrigerator. Okay, a refrigerator will work perfectly when meet the below 3 points. One is proper refrigeration cycle, proper air circulations, and third one is complete defrost cycle. Okay, so defrost cycle plays a major role in a fast-feed refrigerator to maintain the proper cooling. Okay, so if there is any problem related with the defrost, so customer can't happen or machine can't provide the exact or proper cooling. Okay, so in earlier days, okay, or non-mechanical mechanical models, there to complete the defrost cycle, we are generally using timer, bimetal, heater, and thermal fuse. Okay, but in a electronic, semi-electronic models, we are using PCB, heater, thermal fuse, and defrost sensor to complete the defrost cycles. Okay, so generally the defrost heater works on a 220 AC supply and that is directly connected with the PCB through thermal fuse. The defrosting logic is basically most of the engineers question is when a unit can defrost. Okay, basically the defrosting logic is there is a preset program or logic is set in the PCB. Okay, so according to the preset logic or program, when this program according to the preset program or logic, PCB will provide supply to the heater. Whenever the PCB this logic or program will match, accordingly PCB will provide supply to the heater. And after that the defrost will happen. How long? It will totally depends on the temperature of the defrost sensor or the defrost sensor. Okay, until or unless defrost sensor achieve the temperature or sense the temperature plus 10 degree, PCB will provide supply. Okay, that is the main logic. Okay, and whenever defrost sensor is achieving the temperature or sense the temperature plus 10 degree, that is also depend model to models. Okay, then defrost sensor will provide feedback to the PCB, and according to that PCB will disconnect the supply to the heater. Okay, now let's check one by one part and what is the work of this part. Okay, let's so now we will discuss about the checking procedure, defrosting cycle checking procedure of electronic or semi-electronics models. Okay, that is that defrost cycle is compared to PCB, defrost heater, thermal fuse, and defrost sensor. Okay, let's check. That is the main PCB used. That PCB provide 220 supply to heater. Okay, and generally in PCB there is a thick pins and generally mentioned here the supply point from these connectors. Okay, in every PCB the from which pins the heater PCBs provide supply to heater, that is mentioned here. There is a neutral and the heater supply is there mentioned. That is main defrost heater. Generally you use two types of heater. One is metal heater and another one is glass heater. Thermal fuse generally connected to between PCB and heater. Okay, maybe in line or maybe in supply line and neutral line. In both cases, the thermal fuse nowadays this thermal fuse, this is called the thermal fuse. There is two thermal fuses there, and thermal fuse is directly connected with the heater. Okay, in a series. Okay, so one thermal fuse in the neutral line, one thermal fuse in the supply line. Okay, and the working of this thermal fuse is if temperature inside temperature during defrosting, if inside temperature raise more than 76 degree, in that cases thermal fuse will be burned and we can't, and the supply provided PCB to the heater will be stopped, and for that heater will not work. And we have to check this thermal fuse by continuity. Okay, if there is continuity is showing, that means thermal fuse okay. If no continuity is there, that means thermal fuse is open. Okay, in such cases we need to replace the thermal fuse, or if thermal fuse is come with the heater, then total set thermal fuse and heater we need to replace. Then that is called the defrost sensor, and defrost sensor is taking a major role in the defrost cycle, because as soon as defrost sensor reach the preset 10 degree, 12 degree or 7 degree temperature, it give feedback to the PCB, or accordingly PCB stop the supply to the heater. Okay, so total defrosting cycle will complete according to the feedback of the defrost sensor. We have to check the defrost sensor by resistance at kilo ohms. Okay, at 25 degree temperature, the resistance should be near about 1.8 to 1.9. Okay, and but in field you just cross check according to the sensor resistance chart. Now came to the symptoms. The symptom is generally we have found less cooling at refrigerator compartment, and same is the less cooling we can observe at freezer compartment. First, we have to check is there any over icing or over frosting on cooling coil or not. Okay, if there is found over frosting or over icing on cooling coil, then first we start to our diagnosis process. Before starting diagnosis, first we have to check is display is there any error code or not. Okay, for BBM side by side 682 and 683 models, the error code checking process is same, and for other models, first we have to check the error code checking process, and accordingly first we have to check the error codes. So for BBM model, first we unlock the display and press the freeze button and press the power cool button for 5 times. Okay, so is there any error code or not? We have to check first, and accordingly we have to proceed. Okay. For defrost sensor, generally error comes F6, and if there is any error related with defrost, that ED error will come. Okay. Next, we have to check from the PCB through test mode whether PCB the proper diagnosis. For proper diagnosis, now we have to check from the PCB. Okay, through test mode. As I told, if we found any defrost related issue, no need to melt the ice first. Okay, if we melt the ice, then maybe some problems of diagnosis. Okay, so in the PCB, first we need to identify the heater supply line and the defrost sensor. Okay, so this connector, from this connector, the third blue and the red, that is the main heater supply. Okay, and in the connector 1, yellow and the black. Okay, here mention the D sensor, the yellow and in the black, this black pins. Okay, this yellow pins and these black pins, the defrost heater, defrost sensor. Right. Okay, so if we want to check any defrost sensor resistance, so we have to check this from point, and from this point we can check defrost heater supply and defrost heater resistance. To do test mode, first for defrost cycle we have to go to the test 2 mode. For that we have to press this micro switch twice, once and twice, and display will show T2. In that condition, first we have to check PCB is providing 220 supply or not to the defrost heater. If there is a supply, 220 supply, 230 supply is there, that means my PCB is okay, no problem with the PCB. Next, and secondly, same time we have to check is there any ampere is there or not. Okay, so if supply is there, that means my PCB is okay, and next we have to check the ampere. In heater supply line we have to check the ampere. Now here 0.4 ampere is there, that means my heater is working. And this supply, and this ampere will should show till my temperature at the defrost sensor came plus 10. Okay. If before that ampere is off, that means PCB supply is off, that means defrost sensors have or defrost sensor connectors have some issues. Okay. The first checking point, PCB supply and heater on or not. If heater on, then we have to check how long the defrost heater is run. So defrost heater should run till the total ice melt, and plus 10-degree temperature should come at defrost sensor location. But if 220 supply is there, but no ampere is showing in a meter, that means my heater is not working. Now we go to the next steps. If PCB providing 220 supply, but still no supply, no ampere is showing, that means heater is not on. In that cases, first we have to power off the unit and check the resistance at the heater supply point. First we have to check is there any resistance or not. Okay, the resistance may come between 300 to 350 ohms. Okay. So it is showing 350, 347 ohms. Okay. Means my heater, thermal fuse and connectors all are okay. But if no resistance is shows here, if we have no resistance here, okay, that means may problem with my heater or thermal fuse or in my any connectors between PCB to the first heater. And now we have to check accordingly one by one where is the actual problems. Okay. At inside, first we have to identify which one is the defrost heater connectors. Okay, and we have to check defrost sensor connector, thermal fuse connector is separate or it is come with the heater. So first we have to open the defrost heater connectors, and also we need to check the connector pins in both sides are okay or not. If connectors and connector pins are okay, then we have to go to the diagnosis of the heater. That heater or thermal fuse both are okay or not. Now we have to check the resistance from here inside. Okay. So generally, if heater not on, in such cases heater resistance may be not okay. If heater resistance is okay, that time may be issues with the connectors. Okay. So if we don't have any resistance here, in that cases we need to check whether my heater or thermal fuse which one is defect, and accordingly we have to replace the part. As I already told, in these days the heater we are providing is connected with the thermal fuse. Okay, and thermal fuse is either there is a one thermal fuse or two thermal fuse. So thermal fuse is directly connected to the in supply line or maybe in neutral line. Okay, so if we found no resistance at heater, then we have to check whether my heater is defect or thermal fuse is defect, and we have to identify this, because if heater is defect, that means maybe heater damage or the reason is defined. But if we found any thermal fuse is defect, in such cases the thermal fuse defect reason is defrost sensor. Then we have to further check the defrost sensor resistance and connectors. Okay, let's check first whether there is a defrost heater or sensor, which one is defect. Now we have to check both the thermal fuse whether they are okay or not. If this thermal fuse is showing okay, that means only heater replace may solve our problems. Okay. If we found thermal fuse is defect, in that cases we need to check the defrost sensor resistance and connectors. Okay. So if we found any of one thermal fuse is burned or open, in that cases we have to check the defrost sensor resistance. Okay. If defrost sensor resistance is not okay according to our provided chart, in such cases we have to replace the defrost sensor to resolve the issue. We have to check the defrost sensor resistance from PCB also. In PCB mentioned defrost sensor and ground. Okay. Between defrost sensor and ground, we should have the resistance as per the requirement. Okay. If no resistance is found here, that means the sensor is not okay or not good. Some model defrost sensor location never need to change. Okay, and also remember, if we want to replace the defrost sensor, some models there is a no connector is there, so we have to cut it here and properly soldering and insulate. One point also remember, at T2 mode, if the defrost sensor temperature location temperature is more than 10 degrees centigrade, in such cases PCB will provide supply to the defrost heater only for 10 seconds. Okay, and if their temperature is less than 10, then heater will provide supply until or unless the temperature raised to plus 10 degrees centigrade or 12 degrees centigrade or 7 degrees centigrade. That is depends on the models according. Okay. Hope the diagnosis process I explained about the defrost cycle checking procedure will help you in the field to identify the actual defect, and in field also you just first identify the actual problem, which part is defect, and accordingly you have to change the part. Okay, and also remember, after replacing any part, either it is sensor or defrost heater or PCB, again you have to go to the test mode and again check whether heater is working or not. Okay, because sometimes we don't check after replacing the part, we not check, and in such cases repeat complaint will come. Okay, so after replacing the part, go to the test 2 mode and further check whether my defrost cycle is working or not. Okay, thank you.